Please subscribe to my channel and press the bell icon for regular notifications.
Hello everyone, welcome to my channel. Now in this video we are going to discuss the topic of motion of charge particle in electric field. Now the most basic concept is, if you have an electric field and it is directed in this direction, okay, suppose E is the electric field and it is directed in this direction, okay. Now in this region, if I place a charge, positive charge plus Q charge, now this positive charge will experience a force in the direction of electric field. So a positive charge will always move in the direction of electric field. Now similarly, if I have an electric field directed in this direction and if I have a negative charge, and so this negative charge will always move in a direction opposite to the direction of electric field, okay. This is the most basic concept. Now based on this, suppose you have two plates, okay, and this plate is positively charged and this plate is having equal amount of negative charge, such that now these charges are used to set up an electric field in this region between the two plates. So this plate is positively charged, this plate is negatively charged, so the direction of electric field will be in the downward direction, okay. Now let us assume that E is the strength of the electric field in this region and it is directed in the downward direction and it is uniform, okay. Now suppose I have a proton, okay, suppose this is a proton, okay, and this proton, it is at rest and it is dropped in this direction, okay. Now since it is having a positive charge, and as we have seen, a positive charge will always move in the direction of electric field, so this proton will move in the downward direction. Now suppose H is a separation between the two plates and this proton moves from the upper plate to the lower plate, okay, and the proton is dropped. So if the proton is dropped, initial velocity will be 0, okay. Now this proton, it will be acted upon by a force due to this electric field in the downward direction, and because of that there will be an acceleration in the downward direction, okay. So what will be the acceleration? Now acceleration, it is force divided by mass, okay. So here the force is due to this electric field. Now if we take Q to be the charge of the proton, then this F will be Q times E, force equal to charge times strength of the electric field divided by mass of proton, okay. This is the acceleration of proton which is moving from the upper plate to the lower plate, okay. So H is the displacement. Now if I use this equation, S is equal to ut plus half at square. So this S is the displacement, so that is H. Initial velocity is 0 because the proton is dropped from this height, so this is 0. T is the time taken by the proton to travel from this point to this point, so we have taken it to be Tp, okay. T subscript P, so this is plus half, acceleration is this one, so it is QE by mass of proton Tp square, okay. So this becomes H is equal to half QE by MP Tp square. So this is the case when the proton is dropped from this point to this point, okay. Now suppose this plates are flipped, okay. So now what happens? So now this plate is having positive charge and this plate is having negative charges. The plates are flipped. So now the electric field intensity, it is directed in the upward direction. So you have the same electric field, okay, magnitude is same, but the direction is reversed, okay. So this is E, and now the electron, it is, suppose this is an electron and it is dropped from the upper plate Now this electron is dropped from the upper plate and it is moving from upper plate to lower plate. Okay, so now for the electron, similar to the earlier equation, we will have h is equal to 0 times time taken by the electron to travel from this point to this point. Okay, now this electron, for electron again, the force will be q times E. Q is the charge, E is the strength of electric field. Now for both electron and proton, I have used the symbol Q for the charge because both have same magnitude of charge. So Q is the charge, E is the strength of electric field. This is the force divided by mass of electron. So this is the acceleration. So this is half QE by ME TE square. Okay, so this is H is equal to QE by ME, this is half TE square. Okay, so now see both the, so this is the expression for the displacement of the electron and this is for the proton. Okay, now both are covering the same distance. Okay, so since both are covering the same distance, I can equate these two expressions. So I have half QE by MP TP square is equal to half QE by ME T square. I have written these two equations. So this half QE, those things cancels out. So we have TP by TE, TP square by TE square as equal to MP by ME. Okay, now if I remove these square terms, so this becomes square root. Okay, so from this we can compare the ratio of the time taken by the electron and the proton. Okay, now questions have been asked based on this concept in NEET entrance. Okay, now similar examples are also given in your NCERT textbook as examples. Okay, so this is when a proton or an electron are dropped in uniform electric field. Okay, now let us see one more case. Again, let us have two plates. Okay, this plate is positively charged and this plate is having equal amount of negative charge, such that again we have the uniform electric field in the region between the two plates. Okay, so this electric field, it is directed in the downward direction. So I am marking the electric field at this particular point and it is directed in the downward direction. This is the direction of electric field, directed from positive plate to negative plate. Okay, now suppose you have a charge q, a particle of charge q and mass m. It is projected horizontally with velocity u. Okay, now let's see what happens to the motion of this charge particle. Okay, so now see the electric field is acting in the downward direction. There is no force acting in the horizontal direction. So in along horizontal direction, since there is no force, there will not be any acceleration. Now since there is no acceleration, the velocity of the particle along horizontal direction will remain a constant. Okay, but there is a vertical direction acceleration, so there will be a velocity in the vertical direction also. So under the influence of these two velocity, one velocity in this direction and one velocity in this direction, this particle, this is a positive charge particle. Okay, so it is going to experience a force in the downward direction, in the direction of electric field intensity. So this particle will travel in a parabolic path. Okay, so this will be the trajectory of the charge particle. This is the trajectory of the charge particle. Okay, now this, suppose this is x-axis and this is the y-axis. So here the motion is taking place in two dimensions. Okay, so now if we write this equation of motion, S is equal to ut plus half at square. Okay, this is the equation of motion. Now if I break this equation in two dimensions, so along x-axis I will have x is equal to, this is x is equal to uxt. So this is the initial velocity along x-axis multiplied by time plus half ax t square. Okay, similarly along y-axis, along y-axis. Along y-axis we will have y is equal to uyt plus half ay t square. Okay, now let us see what are the values of these coefficients. Okay, see, this charge particle is projected in the horizontal direction, so ux will be equal to u. Okay, if horizontal velocity is u, so the initial velocity along the vertical direction, it will be 0, so uy, it is 0. Now ax, there is no force along the horizontal direction. Okay, so ax will be 0 and ay will be equal to ay, acceleration along the vertical direction. Now acceleration is force by mass, force is charge times electric field, so this is ay is equal to qe by m. Okay, now here one thing you need to note down, that when a charge particle is moving under the influence of electric field, unless it is stated about anything about gravity, then the influence of gravity must be neglected. Okay, if nothing is stated about gravitational force, then you have to assume that there is no gravity, the charge particle is moving in a gravity free region, so influence of gravity must be neglected. Okay, so here, since because of that I am writing acceleration as qe by m. Okay, otherwise there will be one more term plus g related to acceleration due to gravity, that also acts in the vertically downward direction. Okay, so now if I substitute these values over here, I get, for this is x, this is u, this term becomes 0, here this term becomes 0, so this equation becomes x equal to u into t, and this becomes y is equal to half qe by m into t square. Okay, so if I substitute the value of x, this is x equal to u into t, so from this we have t is equal to x by u. So if you substitute the value of t over here, we get the equation y is equal to qe by twice m u square x square. Okay, we are getting this quadratic equation. Now as you can see, this terms, all these terms q, e, 2, m, u square, all these terms are constant for a given charge particle. Okay, so since these terms are constant, this is of the form y is equal to kx square, that is the equation of parabola. The trajectory of this charge particle under the influence of electric field, uniform electric field, it is parabolic, it is following a parabolic path. Okay, now see, while moving in this direction, it is undergoing a deviation. See, this particle was going like this, so it is undergoing a deviation, this amount of deviation from its original path. Okay, so that deviation is measured by this term y. Okay, now if many different types of charge particles are projected having different values of q and m, so in that case you can say that see, for this electric field is constant. Okay, so here this q by m ratio, y, it is proportional to q by m ratio. So the particle having greater value of charge to mass ratio will undergo maximum deviation. Okay, so this charge to mass ratio decides the deviation of a particle in uniform electric field. Okay, so these are some of the concepts related to motion of charge particle in electric field. I hope this video is beneficial to you, and it helps you in understanding questions which are based in your NCERT and also questions which have appeared in entrance examination. So my best wishes for your preparations, board preparation as well as entrance preparation.